So today we are going to design a plate with circular hole. Then after that we will verify in the FEM whether the predicted or whether we design our plate with circular hole is correct or not. So what is our objective is, first we will write our objective. So our objective is design of plate with circular hole under axial loading condition. Axial loading conditions. Our objective is design a plate with circular hole under the axial loading condition. So how we will design how we will design any structure? First things we know, like design of any structure. First things, yes, design of any structure. How you will design? Like we need to make one structure. How you will make? Either someone give the dimension, then you need to tell what is the strength of that structure. Another things, we know the strength of structure, what is the strength of that structure or maximum load that structure will carry, then we will come up with the dimension. So first point is that what we know the strength of structure वो known रहेगा, that is the known, and we need to come up with final dimension of the structure. Final dimension of the second case is that we know the dimensions of structure. We need to know what is the strength of that structure. The strength is unknown. Okay, so strength is nothing but maximum load the structure can carry. So in our case, what is the known? First thing we know whether we know the strength, whether we know the final dimension of the structure. So in our case, so structural representation. So what we know, like this is in our case, this plate, this is the length is 400 mm and width is 800 mm, and there is the circular hole at the center of this plate. Their diameter is 100 mm, but one quantity is unknown, that is the thickness. How much thickness plate we will design. Another things, there is the axial load is there. There is axial load P is equal to 1000 kgf. Okay, 1000 kgf load is given, and material we are taking aluminium 2024T3. So in my case, strength is given. We need to come up with the final dimension of the structure thickness. Iska what is their strength value is known, their young modulus value is 7381.5 kgf per mm square, and FTU ultimate tensile strength of the value is 43.5 0.86 kgf per mm square. So here strength is, this strength value is known. We need to come up with the final thickness of the structure. So how theoretically how we will calculate what is the thickness of the structure? The first thing we clear here, first case will be applicable. Strength of the structure we know. We need to come up with the known final dimension of the strength of the structure is known. We need to come up with the final dimension of the structure. Okay, so how we will first theoretically predict, then we will go for FEM, because without how we will match if we go directly with theoretically. So what is the methodology we will use? Methodology. What we will use? Maximum stress is equal to the strength. Maximum stress is equal to the strength. So here strength known. We need to calculate the stress. What is the stress? So stress is P by A. So we need to calculate for FEM, like so P by maximum stress is equal to no. So here sigma max is equal to the, how much we are getting? 43.586 kgf per mm square. So area, what is the area? Area is always width into thickness. So here thickness is the unknown. Like so sigma is equal to P by W into T is equal to the 43.586. So here load is known, width is known, thickness is unknown. But there is this problem is that this stress formula P by A is valid only for when cross section is uniform. This is valid only for uniform cross section. If you see here, in this case our cross section is not uniform. Here is the non-uniform. In this region, if you see here, till here to here it is uniform, till here to here is uniform. But in this area, in this area, my cross section is non-uniform. If you draw the cross section, okay, if you draw the cross section here, so it will be like, so if you see here, my cross section is non-uniform. Here is at the end it is the uniform, but there is the non-uniform cross section. So this formula P by A is not valid. So here the idea will come up with the stress concentration. Stress concentration. So when, what is the stress concentration? Concentration means there is one thing need to concentrate at a one point. Stress concentration, there is a stress is concentrated at a point. Okay, so if you see here, this is the plate our, this is the circular hole. Okay, here load is applying 1000 kg. If you see here, like if you see the stress distribution, see the load path. Let me use, look at here to here it is uniform, load path is my uniform. But if you see here, this is gone, but it need to travel here like this. Again you see my stress, my load path stop, it need to go from above, from above, from above. So at this region my stresses is concentrated, my stresses are more, stress is concentrated at this point. So what is stress concentration? How we will come up with change in load path. Load path is nothing but the imaginary path taken by the load from point of application to the fixed end, point of application to the fixed end. So when there is a change in load path, if you see here there is a change in the load path. Here there is no change in the load path. Here no change in the load path. Here no change in the load path. But if we see here change in the load path. So if there is a change in load path, another thing what we observe from here, sudden change in geometry. If you see till here my plate is uniform, there is nothing, but if once come up here there is a change in the geometry, there is the hole. The stress concentration is there is a change in geometry. So how will till here my sigma is equal to P by A is applicable, I can calculate the stress. Okay, but if you see here more stresses, so we need to come like we think like that, how much more stresses is there. So if we compare, if we give the region 2, this is the region 1. So if we compare like region 1 and region 2, so how much more at R2 region there is a more stress, but how many times it is more? If you so there is a constant, it's called KT. The constant is called KT, that is equal to region. So the stress concentration factor. So second term we will use the stress concentration factor. Stress concentration factor. Stress concentration factor. So what is the stress concentration factor? Like how stress concentration factor is how much times stress is more in compared to the other region. So at the circular here stresses is more. So either chances of, because here is the chances of the failure will more. So how KT will calculate? KT will the stress concentration factor, it will calculate by using D diameter by W ratio. For this you need to refer the book. In that book we can get the KT value. That book name is Peterson stress concentration book. By that book we can get it. So then there is then how we will calculate the maximum stress? So calculation of thickness. So how we will calculate the thickness? So here we will use, like here my that P by A is not vary, so here we will use sigma max is equal to the KT times sigma nominal. What is the maximum stress we will get? So see our this plate, load will apply, load here load is applying 1000 kg. This is the fixing if you see, like here will be the maximum stress, here will be the stress, here will be stress, here will be, what is the nominal? Nominal is the region with cutout. This is the nominal, this is the net, or we use the term gross region. So here how much is the nominal multiplied by kt will get the maximum stress value. So we will use, so what is the design criteria? डिजाइन क्राइटेरिया क्या था मेरा? सिग्मा मैक्स इज इक्वल टू द स्ट्रेंथ. ओके, तो सिग्मा मैक्स इज इक्वल हाउ मच स्ट्रेंथ वैल्यू विल गॉट इट? you see 43.586, 43.586. okay, so we'll use these things here in this equation. Sigma max is equal to the kt into sigma nominal. okay, so sigma max we know 43.586 kt value here, kt value I will find out from the graph. Sigma nominal is p by w minus d into t. I told now there is the nominal, so I will calculate. So this is your width. okay, this is your width and this is the your diameter. okay, so to this region my, if you mark on this pen, this is the cross section we are considering. okay, if you see like here, you can tell the plate will be like this way thickness. So this is the region, this particular region is sigma nominal, the p w minus d into t. So we will calculate the kt value.